Hello everyone. In this video I'd like to present my solution to the following problem from Swedish Mathematical Competition final round 2022, problem number 2. We wish to find all the functions f from real numbers to real numbers such that the following functional equation is satisfied. F of x plus z times f of y equals f of x plus z times f of y. Okay, so I will give you some hints. This problem is not very hard, to be honest. The first hint, are there any obvious solutions? Maybe they are. And then, apart from the obvious solutions, you can try plugging in some numbers. For example, x equals 0 may be interesting, and so on. So, give you a try if you wish. Okay, so my solution. First of all, let's notice that function which is constantly 0 satisfies the equation. It's obvious because 0 equals 0 plus z times 0. Nice. So now let's suppose that there is some real number, let's call it y sub 0, such that f of y sub 0 is not 0. In other words, the function is not constantly 0. And let's plug in x equals 0. What do we get? We get the following equation. F of z times f of y equals f of 0 plus z times f of y 0, I should say. And plug in x0 and y equals y naught from the above condition. Okay, and now, a very important thing, let's look at this function as a function of variable z, because z is arbitrary, there are no constraints of z. It's easy to notice that the function which takes real z and maps it to this number, this function is surjective. Why? Because it's a linear function which is not constantly 0, because by our assumption this number is not 0, so we can get any number whatsoever. So, in other words, since this function is surjective, we can say that for every real number t, there is a real number z such that t equals z times f of y0, and our functional equation has the following form. F of t equals f of 0 plus t, because here again it's exactly the same as here. Okay, so we have the following, and it's almost the end of the problem, but it's very important to check if this proposed solution is really a solution. So let's check. So our left hand side was f of x plus z times f of y. So let's plug this derived formula for f of t. We get x plus z times f of y plus f of 0. Once more, we have f of y. F of y is y plus f of 0 plus f of 0. So it's just x plus y times z plus z times f of 0 plus f of 0. It was the left hand side. What was on the right hand side of our equation? There was f of x plus z times f of y. It's x plus f of 0 plus z times y plus f of 0. After expansion, it's x plus y times z plus z times f of 0 plus f of 0. Exactly the same. And one more thing, f of 0 is arbitrary. There are no constraints on f of 0 whatsoever. So, in other words, our solutions, we have two families of solutions. First solution is function which is constantly 0, and second family of solutions is x plus b, where b is any real constant. You can think that this b of 0 is f of 0. Yes, b equals f of 0. And I believe that's it. It's our solution. So we have infinitely many solutions, and it's nice. So thank you for watching, and see you next time, hopefully.